Doesn't mean his name is Connor.
Okay, so our first one, I'm going to make a public static method. I'm going to make its return type a double, and I'm going to call it do stuff, and I'm going to pass in a string and a boolean. So I'm going to make a public static. I said I'd return a double. It's called do stuff, and I'm giving it a string and a double. Just like that. So our next one, I'm going to do a public static. I'm going to have a void, no return type. I'm going to call it a lot of stuff. And I'm going to pass in 3 strings and 2 integers. So you do it just like that. Okay? Oh, is it too small? Okay. So here's the example. Here's 2 example ones. Again, you could do pretty much any set of numbers and strings, booleans, integers, doubles, floats. Whatever works, they're all fine as long as you created 2 with a differing amount of parameters and a differing return type. You're good for me. So now we're going to actually do a little bit more about calling methods and doing with that. I'm just going to continue down the same thing. So we're going to talk about a little bit of basic math, some functions that we do. So we're going to do an average function that computes an average given some values. What we're going to do is we're going to make a public static method called average, and we're going to pass in an integer array. Okay? So you're going to want to create this method. Public static, it'll return a double. We'll call it average, and you will pass in as a parameter a singular integer array. Why do you have gloves? Okay, bye. Okay, so we got that? We're good on that so far? So what that would be is a public static. I wanted a return type of double, and I wanted it to be called average. I'm going to call it AVG for short. I wanted to pass in an integer array. I'm going to call it numbers. What I just said you should have done. What we want to do is we want to be able to pass this an array of values, and we want it to compute an average. So there's a couple things that are useful to help us do this. For one, we're passing in some integer array of numbers, and remember, it's not a defined size. So the important thing to do is whatever that size is, we need to make sure it adapts. So the first thing I would do, I'm going to define an integer called length. Or I'll just call it size, why not? And I'm going to make it equal to numbers.length. Oops, mistake. Oh. So, hey guys, so what I did was I made this call, I made average. What I'm going to do is first is get a size, just so that I know the amount of numbers I'm dealing with right at the very start, okay? So I want to compute some average. I'm going to use a for loop to do this next part. And now that we have a size, we can use it in our loop counter. So, guys. So the reason we created this numbers.length and it'll work is that this size will be the amount of numbers we pass in. If we pass in an array of length 4, it'll give us our size is 4, and the valid indexes of our array are then 0, 1, 2, and 3. So our counter can go from 0 up to whatever size is, and it will correctly grab every single index. Okay. So one more number we need. I'm going to create a double. I'm going to call it answer. I'm going to set it equal to 0 to start. So the first thing we want to do is we want to, every time through the loop, we want to add the number to our current running sum. So I'm going to do answer equals answer plus numbers I. So far what's happening is we're just going to sum every single number up. Right as we exit this loop, the current thing we're looking at is the sum of the number of all our numbers in our array. So we're pretty much good to go. We're going to return now, because now that we're done, we're going to return a number. And we're going to divide by our size. We're good to go. Are there any questions about our average function so far? Anything at all? Return? We don't know what that is, dude? Yes. Okay, so return. Basically, we're going to call this function. From before, we usually print out information. We're now going to deal with, be careful around the computers, please, with that, and poking other people in the head, which you're about to do. So, return. So when we call functions from before, we usually printed things. A better way to think about functions is that they are like a worker. So from before, our worker would do a task that we gave it, and it would print something to the console, but there are times where we want our program to know more about what it did. So for example, printing out that information is nice, but maybe I want to use the function later. So I am going to, it's going to return, when I do a return, it will replace wherever that function is with whatever it returns. So for example, if I call average, if I try to print out average numbers, it will run the code for the function, the method average. It will run it, it'll get something, and it will give you back numbers divided by size, answer divided by size, and it will just print that out directly. That's some numerical answer that will come out. So I'm going to show an example of that. We're going to make another one. It's going to be public static int, and we're going to make it called sum, and we're going to pass in our integer array of numbers. So what we're going to do is we're going to take this out here, this part right here with our answer. We're going to paste it down here. So I'll make this sum. So we're gonna. Okay. So what we're doing, I'm making another function. So now you have a method. Where I have two methods now. We have one that's sum and one that's average. So we're gonna do a run through of what this does. numbers. Perfect. Okay. So basically, we have our average function. We're getting a size, and then we're getting a sum. We're going to use our sum function to calculate the sum for us, and then we're going to use our average function to finish it off. So really quick, I'm going to run through what it's like to call this function. So we're going to create an integer array of some values. We're going to do the values from 1 to 10. Whoops. So, wait, what's so hard? Wait, so far. Slower? Okay. So here's the two functions. You're going to want to copy these down first. Okay? Is everyone good? Do we have these methods copied down? Both of them?
No.
Still working? Okay. Are we good so far now? You getting it? You got these copied down? Good to go? Hey guys, is anyone not done typing these down?
It doesn't win. There's an error.
There is an error.
There is an error.
Where? I do not have an error on mine.
You're an error. You are the error. What? What are you saying?
Make sure to copy this down. Be very, very specific when you copy this down. Make sure it's exactly the same, or else you're going to get some unintended things. Make sure size is double, int is a num. When you call sum, you call sum equals sum numbers. Are we good? Hey guys, is everyone, we got this all good? Copied down? No errors, just confirming. We good?
Can you go to line 1 through 10?
Yeah, we're gonna get to that in a moment. But has everyone got this part? Good to go?
Yes, sir.
Okay. So we're gonna run this little part in our main really quick. So we're gonna run this. We're gonna see what happens. I'm gonna pull up this thing called debug, and I'm gonna be able to step through our code line by line. I'm gonna see if this will be kind of experimental. I want to see if this is helpful or not when we do that. Okay? Yes.
Why is there a array called values, but everything else you have is called numbers?
When I pass in the variable, I don't have to give it the same name repeatedly. So I called it numbers and I called it values here. You can change the name of things when you pass them in.
But it shouldn't matter if they're all the same, right?
Yeah. The only thing that has to be the same is the order. So if I pass in an integer array, if I pass in a boolean, I couldn't do boolean integer array. I'd have to do integer array boolean. But I could my integer array could be called Steve, and then in my method it could be called values, and that's fine. Or it could go Steve to Bob in the method itself too. Again, those are fine. So do we have this all good? So are we good? Everyone ready to go? All right, so we're going to run the code. Does anyone know what the average of the numbers from 1 to 10 are?
5.5.
5.5. We're going to run it. You are correct. It should be 5.5.
It said compilation error. Your compilation error. We need one more. I need one more. We need one more.
5.5.
Sorry. I just need it. You need to see
Yes. What now? Ending brace reference. So see how my main is brace, and then I have another method. You're currently starting trying to add methods inside of another method.
It's true. And I realized that I was never this stupid. My friends were never this stupid. Y'all are just dead.
Okay, is anyone not getting 5.5? Okay.
I wish you were called you. Please, that's what it's food. This one will be there already.
Public static.
That's not okay.
Is anyone else not getting 5.5? Number and not numbers. You can leave the estimate here.
Just dude, get a little bit. What a loser.
It's called the grammar function. Oh no, wait, give this. You can delete the S, just make sure to delete the S there. And, yeah. Okay, is there anyone else not getting 5.5? Are we good? Okay, so we're going to really quickly run through what happens, and so I'm going to explain it once this way, and then I'm going to go for the debug version. My debug allows me to step through my code line by line, basically seeing how the computer executes it, but I get to choose when it moves to the next line. Okay? But for the start, we go into our main, which is our starting program. We create this integer array. It has 10 values. We give it the numbers 1 through 10. Then what we do is we want to call print line, and I want the average of all my values. Okay? So what it does is I'm going to call print line, and then it says I need to compute what average of values is. So I scroll down to average right here. So I look at what I passed in. So now remember what was called values, that integer array is now called numbers. So we create a size, that's the numbers in length. So there were 10 numbers there, so this number will be 10, that double size. Then we say int sum equals the sum of some numbers. So sum is another method call that we make. So we can scroll down here. We look at our sum. Remember, we passed in again that values or that number array. So we create a sum, it's 0. Then we go through our entire array. So we start at I equals 0. We add, remember sum is currently 0, so we do sum is sum plus numbers at index 0. So we'll add 1 to it, we get 1. Then we increment I, we get to I equals 1. 1's less than 10, which was numbers.length. And we get 1 plus 2 is 3. So then we increment I, we get 4. So we get, 3 plus 4 is 7. Then we do 7 plus 5 is 12. 12 plus 6 is 18. So on and so forth. Eventually we're going to get to 55, which is our sum of all the numbers from 1 to 10 at the end of the loop. At that point, we return sum, so we go back to where we were, and that sum that was returned goes right here, this integer value sum. Then, from here, we return sum divided by size. Sum was 55, size was 10, so we return 5.5, and it finally gets back to the print, and it prints it out. Okay, was there any question about that? Yes.
Why do you need to declare size as a double as opposed to just an integer?
To avoid integer division. If you declare this as an integer and then try to return sum minus size, it would return 5, just straight up, 5.0. Because it would do integer math and then return it as a double.
So as long as one of them is a double, then it
Yeah, because doubles are bigger number type than ints. It's easy to make an int a double, but if you make a double an int, you lose the decimal. So. You could also make sum a double and size an integer. Both are fine. Okay, so I'm going to really quickly set up debug. I want to see if this is helpful. Oops. Nope. Okay. So I'm gonna scroll up, get a lot of the code shown here. So the line highlighted in blue is the line we're currently on. We're gonna step through it line by line. So variables are gonna appear down here, and we're gonna see basically how it goes. So what we do is we create values. It gives us this set of numbers. As you can see, it pops up in our variable list. It gives us an option. We can just kind of look at it if we want. But what we want to see is it trying to print out the average of values. So the first thing you do is we jump into average. We gave it this thing called numbers. So it has the integer array numbers. Then we compute the size, which is numbers.length, and get our double size. So our size becomes 10.0. Okay? That was just getting the length of the array and then storing it in a double we called size. So now we're calling sum, and we're calling our sum function. So we're going to jump into this. So now we're at our sum. Sum is 0. It gets our own little variable right here. We're basically going to step through. We have a new variable created called I, which exists there. So we do sum equals sum plus numbers I, which will add the 1. So our sum is currently 1. We double check that our counter I is less than the length. So we add it, we get 3. Our I increments to 2. We're still less than length. So we add it to 6, which is the 3 plus 3. Then we do sum 3, we do 4. So that's 4 plus 6, which was 10. Then we get 15, then 21, then 28, then 36, 45, and finally 55 on this last one. So right now, I is currently 9, but so I went to 10. Then we checked 10 against length, and 10. So now we're back over here. So the sum was now 55. We're returning this. So this is the important part you want to watch right here. Was as we finish that, we go back to where we were in that last method. Okay. Execution of that method stopped while we did other things. Okay. Once we ran into something we needed to do, we went to go finish that before we continued what we were doing. Okay? So, now that we're back here, we computed yes.
So the reason why we went to method 3 was because integer sum isn't defined in method 2 in the second method, so you have to make a separate program for it.
Yeah, I'm just making a couple of methods to show you what it looks like to call multiple methods. So, like I said, the important thing to note is that we went from method 1 to 2 to 3, then back to 2. Okay? Because it didn't finish, we have to go back and finish it now. So, sum was 55, which we now know. So, sum was 55, size is 10. We're going to do division with that. And it's going to return us back here to our print line. What it's going to do now is what you're going to see. So remember, we were turning 55 divided by 10, which is 5.5. Right here at average values, we made a function call. It returns some number. The easiest way to imagine this is whatever is returned from a function replaces the text that it was where it was. So 5.5 is our returned answer. Imagine replacing average values with 5.5, just the number 5.5. Okay? So when we get to printing it out, which is going to be, we're going to finally finish our original method call. We get our 5.5 and the program finishes. Okay? Was there any question about how we jump from method to method and how the numbers were saved between methods? Are we good on that? Makes sense. Okay? Good? Not good? Confused? Confused? Okay. So, going through this, whoops. So, when we were, I'll run through it one more time. When we were executing average, we ran into a function or a method called sum. Sum is a method we have to call to do some work. So, while we're in the middle of average, we stop executing code on average, and we have to go finish sum. Because to finish this line of code, we need to know what this actually gives us as an answer. So, basically, we jump down to our sum. And we have to do all of the sum work before we can go back and finish average, okay? So, sum, basically started from 0, we summed up all the values, and then we returned it. So, up here, I remember that sum was 55. So, back up here, we said int sum equals, and we called our method sum. The answer, the thing it returned was 55, so we can replace some numbers with 55, and imagine it just says int sum equals 55. And that finally, that executes and just stores our sum 55. So then we get we're returning 55 divided by 10 as for a double. So, and that's where we were executing this line originally, print line, on average values. So So because average values return 5.5, we can imagine replacing that with 5.5 and just printing out 5.5. Okay? Yes. 55 is the sum of all the numbers from 1 to 10. Just you can check on the calculator if you want. But okay. Any other questions about how we called methods? This is called flow control. And what this is calling methods and methods and kind of figuring out how it works, okay? Good? So we're going to do really quick one more for you guys to look at to kind of, again, figure out this concept of how methods execute. Close this out. So, what's going to happen is we're going to create a couple methods on our own. So you don't need these anymore. So what we're going to do, we're going to create a couple methods. You're going to basically see how the methods operate and move around. So we're going to create a method they're all going to be public, static, and void. So they'll all have this kind of thing. So we're gonna make this one called method 1. We're gonna make another called method 2. And we're gonna make a third called method 3. And we'll make one more called method 4. Why not? Okay. So
Slightly fast.
So once you have all 4 of those, just let me know.
Wait a minute. What's the stuff above that?
You don't. It's gonna be blank. We're gonna change that. This is what you want to add. These 4 lines of code, or I should say these 4 methods is what you want to add.
Wait, we add that?
So we delete everything.
I deleted everything.
Yeah. So you can keep your main. We don't even need the numbers. We just need our 4 methods and our main method, which can be empty. We're not going to use it yet.
Interesting. You know you're exquisite and learner. As a boy, you talk about the one that's general. Oh no, I make very little. I said not method. That's immediately. As a boy, you talk about the one that's general. I see the trees. It's all stuff sliding to your DMs. It's all sliding.
Are we good so far? Are we all ready? Next part? Okay. This next part you're going to be able to copy and paste. I'll just tell you now. Are we ready? Next part? Thumbs up, thumbs down, not, no? Yes. Give me a second? Okay. Exactly 1 second. Oh, you're out of time. Okay. So, basically, we're gonna add
Wait a minute.
we're gonna add a couple of these.
A couple? Oh, you're really a quartet?
So,
You want to be
couple print lines. Like I said, if you do not know how to copy and paste, this will be a great time to learn this keyboard shortcut.
Wait, what is it?
It is Control C on Windows and Command C on Mac.
Really? Yeah.
It allows you to copy a text you highlight to your clipboard. You may then use Control V if you are on PC or Command V on Mac to paste said text repeatedly.
What is a clipboard?
The clipboard is this magical place that stores what you copy.
Oh, what if I made my own computer from the potatoes?
It probably does not have an operating system that
It
supports
does,
that.
though. I call the operating system Juneport. What a nice operating. See, like, Juneport, what's 1 plus 1?
So are we good?
Can you copy paste right? I did it right. What are you talking about? 1, 1, 3, 4.
Like,
Oh shit.
according to
Hey,
your
language. There's a 4-year-old here.
I'm a 4-year.
How old are you?
I'm 142.
Are we good, guys?
He said 4.
Hey, do we have all this typed out? We're ready to go?
Yeah.
Okay, we're going to do some method calls. But before that, we're going to do a little bit more copy and pasting. So for everywhere you saw that, we're going to add a finish now. So we're going to...
It's like my life is a lie. What are you? You don't say what are you?
So,
Why are you lying?
because I said so. Gosh. Because we're gonna do another little demonstration of how these programs execute.
Wait, hold on. Before you do that, excuse me. Stop. You get something. You don't have friends over for
At least I have friends in it.
I kind of like it. I kind of like this here.
Do you need some water?
Wait, he's so savage.
I'm not savage.
He knows the guy. Oh, his dad's a rapper.
My dad's a rapper.
SoundCloud rapper, though.
That was
SoundCloud rapper.
There's people in our school. Little young dude.
What?
I'm gonna go play some sound. Follow my SoundCloud. What is it? Young Nody. Young Nody.
Do we have this down, guys? Are we good to go?
Yeah.
Wait, no?
Yeah.
Is anyone not done with this part?
Yeah.
We're good? Okay. So, scroll up to method 1. In method 1, call method 2.
Why?
Okay? In method 2, call method 3. And in method 3, call method 4 twice.
Wait, hold up. Hold up. It was the button. Hold on, what's it? Wait. What's it? Oh, wait, there it is. Slow down.
So,
Horses.
here's all the modifications you're making right here.
I am a auto. Why are there 2 in the second one or the fourth one? Third one.
Because it's third one. And because it's going to show, again, it's for the learning.
did it wrong. I did it wrong.
They're wrong. I don't know what life is. Okay.
Life is pointless, and the only thing you do is pay taxes and die.
Okay. Oh, rods. Like your kid's around here. You should. He's right there. He's gotta know what he's getting into. The future is bright.
The future is bright. Pay taxes. Pay taxes to your overlords. What? Overthrow the government? I don't know about communism. I like having food though.
What? I'm gonna talk to your mother about this. You lose a trash can in your sink.
Okay,
are
are we good, guys? 4 lines of code added?
Stop moving, I need to work.
Okay, wait, so
Are we ready to go?
can you go to the method
No.
4?
Method 4 has no changes.
Okay. No, your salvation comes from.
Are we ready?
Wait, go back to there so we can.
Wait, stop right there. Stop right there.
Okay, guys, ready? We're going to the main method. We are adding a single line of code. We are calling method 1.
What? We have another method? Wait, what? There's more? Oh shit.
This is in the main. You should have a method 4, yes. Here's what all your methods look like. Here's method 1.
I can't. Hold on.
Method 1 has a print line statement that says method 1 start, then it calls method 2, then it has a method 1 finished print. Method 2 has a method 2 started print, then it has a method 3 call, and then it prints out finished. Then our method 3 has a method 3 start, 2 calls to method 4, and then a method 3 finished. Our method 4 has a method 4 start and a method 4 finish. Okay? Are we good on that then? Okay, so what you got to do is you want to take method 1 and you want to run your code and you want to see what it prints out.
Let's run, boys. Wait, wow. Chichi Daisuki Nagayo.
Shut up.
Error? I got an error.
If you deleted it, did you recreate having the class part, the public class?
I might have actually.
I am just going to use method 4.
Oh yeah, I definitely did.
What's the best way?
Wait, wow. Chichi Daisuki Nagayo.
There is yours. Oh, right.
Oh.
No.
Do it right.
Oh no, I just messed up everything. I just messed up everything.
So the method 2 starts. And then
Wait, I'll be the go back to the next one. I'll be the wait. So I can be the wait. How do you read this? Wait, it says error.
method 4 on the parent server.
What? I don't know what's on your line.
Method underscore.
What?
Yeah,
Underscore.
yeah, you can't use spaces. I use
Yeah,
underscore.
read this one. So you can. You ready?
What are you grabbing?
I don't know yet. Oriwa, Chichi Daisuki Nagayo. I suggest the UN Beijing International.
You sound like an Indian speaking Japanese.
That's what That's literally what I am. What is this class? Whatever. Shut up.
I still.
Roman likes OG cheese.
I can see your world.
Did we all run the code?
Yeah.
Okay.
Oh, I got everything wrong.
Hold on. Run. Why? What's wrong with that?
How close are you?
Underscore my dude. Oh, never that. Here, I'll just no. Sorry.
What
What is it?
underscore?
Whatever the name of it.
Space name? Everywhere else.
I'm looking at these
All
now.
methods? Yes. It's only 4. So no spaces or.
Oh no.
I know the way now.
Okay.
Thank you.
Your string args thing.
One hand.
I know the way.
No, running. Make sure you guys have 4. By the way.
That's it. I'm being no.
1, 2, 3, 4, 4,
Underscore there. And now it's just.
You get 2 4s.
Oh, what?
Yeah.
Each person gets one. Hey, 20.
Cards!
Yeah, that's it.
Cards?
Satya.
Wait, cards?
We're supposed to look. It doesn't matter what you get. Actually,
Yes.
bucks right now. Okay. The mafia. I look part of it. Chicken mafia. Okay. So. Chicken mafia.
Okay, guys, what did it print out? What did it print out, guys?
Method 1 star, method 2 star, method 3 star, method 4 star, method 4 finish, method 4 star. Okay, I'll look down. Yeah, whatever he said.
Okay, so what you should get is method 1 start, method 2 start, method 3 start, method 4 start, method 4 finish, method 4 start, method 4 finish, method 3 finish, method 2 finish, and method 1 finish. Okay? So,
I don't know what the heck you did wrong.
Your mom.
So really quick, guys. Hey, guys, come on. Well, so basically, what we have is called a call stack, and we're going to simulate this with cards. Okay. So here's how this is going to work. I gave you guys some cards, and what we're going to do is we're going to place cards down when we start a method, and we're going to pick cards up when we finish. The important thing to remember is this: when a method finishes, you can only take something off the top of the stack. Okay? You can only take cards from the top. You can only place cards on the top. You can only take cards off the top. Okay? So start with all 4 of your cards. It doesn't matter if they're face down or face up for now. Basically, we're gonna. Okay, guys, we're gonna follow this method, and we're gonna see what happens. You're gonna get a nice visualization. Okay? So, first thing we're doing, guys, we're calling method 1. So put your first card down. 1 card. So you have 1 card down, right? That was the method 1 starting. Okay, we can agree by placing it down, we started the method. So we start method 1, then we say we're going to call method 2. So card number 2 goes down. Okay, that was our method 2 start. Now we're going to call method 3.
Is your shirt?
So, hey guys, come on. So we have method 3. We put down that method 3 start. Now we're going to call method 4. So we put down our 4th and final card.
Wait, what?
Method 4 starts, then method 4 finishes. Once method 4 finishes, you can pick up your card off the top. So guys, we finished method 4. Pick up your card for method 4. Put it back in your hand. Okay. So now we're back at method 3, right? On the stack, or on that 3rd method. We're going to call method 4 again. So, like one more time. Put down the card, starts the method, we finish the method, so we're going to pick up the card one more time. From here, now it says we're finishing method 3, so we can pick up that 3rd card. We go back to where method 3 was. We can now pick up that 2nd card because method 2 finishes. And finally, we're back in method 1, and we can pick up method 1. Method 1 finishes, and we're back where our program ran, and we finish the program. Okay? Was that clear? Did that make sense? Because we're going to do this one more time. Okay, so we're gonna change up the methods, guys. Keep your cards. We're gonna flip up the methods, okay? So
Watching video. That is Calvin.
Okay, so here, guys. Here are you? We're gonna mix it up a bit. So we have method 1. Method 1 is gonna call method 3 now. So just adjust that line of code real quick. We good? Then method 2. Method 2 is gonna call 1 then 3.
Wait. Okay, cool.
Method 1 calls method 3, method 2 calls method 1 and method 3, and then method 3 does.
Oh shoot! Yeah, that's right. Shoot.
Okay, are we good?
Right. Wait. Yeah, dude, it just copy and paste. Oh my god. I'm not a good, hard-working citizen, so I type.
The charging cable? Or are you?
Very bad.
Definitely.
You ever say water and that clown?
Calls 1
Does he doesn't even know?
Okay, guys, you make these changes?
Wait, that changed? Is that it?
Yeah.
Okay, cool.
Okay.
Wait, you do method 3 to wait, what? No. Yeah.
Ready?
That is.
Yeah. So in our main, we're gonna call method 3. Okay? Instead of method 1.
Wait, what? Oh, never mind.
I'm so confused.
Do we run it?
Yeah, we're gonna run in a moment.
Did I get it wrong?
Oh, fine. You He's great grandfather.
No.
Okay? We ran our code. We got, you should get method 3 start, method 4 start, method 4 finish, method 4 start, method 4 finish, and then method 3 finish.
Interesting.
It's over etiquette. I have to hide it.
Okay. So, one more time, we're going to run through with the cards one more time. Again, we're going to see what happens. So, we start with our main function. We got all our cards currently in our hand ready to go. So, we call method 3. So, we can put down a card. So that's our method 3 start. We then call method 4. So I put our method 4 card down. Method 4 starts, then method 4 finishes. So we go back to method 3. Then it calls method 4 again. So method 4 starts, and then method 4 will finish again. Then we go back to method 3. And we go back to method 3. Method 3 finishes, and then we're back at our main, and the program exits. Okay? So that was one more, a little bit more simplified. Okay, yes. What? From where? What do we call this whole thing? This is called a stack. Yeah, that's where you can stack the cards. The concept is exactly the same. Hey, guys, come on. Okay, ready? We're changing it back to method 1 one more time. This is going to be the most complicated one we're going to go through, okay?
I don't like that.
So, we're going to call method 1 in the main, and we're going to run it.
Wait, is that it?
Yeah.
Okay.
I'm scared.
You're going to get a nice stack of calls.
Oh my god. Why are there so many fours?
It's over etiquette. I have to hide it.
Oh, you got 2 8s and 2 2.8s. You know what that means?
Okay, are we ready for this? We ran the code. We ran method 1. Are we, guys? Did we run method 1? Ran it. Good. Okay. We're gonna run through it. So, what you should get is just like this. You're going to get method 1 start, 3 starting, 4 starting, 4 finishing, 4 starting, 4 finishing, 3 finishing, and then 1 finishing. Okay?
What's the teaching? I don't know what the heck I do. What is it? What? How come mine is everything?
Some shit.
Mine's the same on the board. And you want me to know the
What? Do you know bondage?
Are we good, guys? Ready to go?
Yeah. Sleep. Yeah.
I see.
Okay. So, really quick, this will be the second to last one. The last one's going to be the most ridiculous one. You don't have to follow this one with cards. The next one you definitely want. So, what we do is we start with method 1. So method 1 starts. If you want to follow with cards, you can. You can put down your first card. Method 1 calls method 3. So we go down to method 3. Method 3 will call method 4. So we can put that card down. Method 4 finishes, so we can pick that card up. We call method 4 again. So we put the method 4 card down again. Then method 4 finishes. Then so you can pick it up. Then method 3 finishes. So method 1 can finish. And we're back to the top of our program. All right, so we're going to do one last one. This one you're going to want to do with cards. You want to think about this one. How is this program going to execute?
Then wonder, leave check.
You want to look, probably want to think about this one first. Run method 2. You're going to get a nice stack of calls.
Method 2, start. Method 1, start. Method 3, start. Method 4, start. 4 finish, 4 start, 4 finish. And then 3 finish. And then 3 finished. 1 finish. 3 start. This one. And then 4 start, 4 finish. 4 start, 4 finish, 3 finish, 2 finish.
So, are we ready, guys? This will be the last one with the cards. Okay, ready? Please do not. Okay, so here, guys. Ready? We're calling from the start. We're calling method 2. First card down. Method 2. From method 2, we call method 1.
Yes.
And 3.
Then from 1, no, remember we're following this line by line.
Oh, okay.
So we put down our method 1 card. Then we call method 3. We can put 3 down. 3 calls 4. So we put down 4 down. With 4 finishes, so we can pick up 4. Then we call 4 again, so we put down the 4. Then 4 finishes for the second time. We pick up 4. Now 3 can finish. We go back to method 1 where 3 was executing. We finish that. So we jump back to method 2. So now we should only have 1 card left on the pile. We then call method 3 from method 2. So we go down to method 3. We put down our method 4 card. Then we pick up our method 4 card because it finishes. Then we put down method 4 as we call it a second time. And then we pick it up as 4 finishes. Finally, 3 finishes one more time. We go back to method 2 where we were. 2 can finish, and we're back at the start of our program. So, what concept we just went through a few times now is called the call stack. It is a call stack, which is the methods we call in order. The reason it is called a stack is because every time you call a new method, it goes on the top of the stack, and for a method to finish, everything that was called before that was called before it, like in the execution of it, has to finish before that can be done. Okay? So to reiterate, if in method 2 you call method 3 needs to fully complete before method 2 can complete. With a stack, just like the program stack or any stack of numbers, you can only put and take off the very top. Okay?
I don't get how it stacks and stuff. I'm confused about how it works. So it goes with it.
It's just you don't want to think about the program in context. You want to think about if I call a method inside of another method, that first one, the one I just called, has to finish before the original can finish. When you call another method, you put another card down. When a method finishes, you pick the card up. So for a method to finish, every method it calls has to finish first. Okay? So that's what the cards are for, helping you see that when you make calls, and they have to finish before you can finish the original. Okay?
Why are you making the That's just why you're able to work one less than you think. I think you did. You just thank you.
Okay, are we good on this concept, guys? I'm gonna collect the cards now, though.
How do you know the lyrics to Caillou? Because he's fucking Caillou. This. The PBS.
That would be so think about it. If C equals D, and D equals C.
What is it?
So if C equals D, D equals C.
What are those?
C equals D, D equals C, C equals D.
What if I asked it? What's up? Yo, you know how old I was? You know what age are you now?
Yes.
You know what that is? I was 643.
You said C, D, and C, D. You probably right now some other variable to make it like some counter.
Really? I thought that was 14. Yo, are you okay?
We have to make an execution after.
Parents be like, dude, she's like, how old? 9. You know what? I thought I was 10.
Okay, guys, we're gonna do. With that, we're gonna do a couple of exercises.
There's only 2.
So we're gonna.
I got exposed.
So you guys can keep these methods and fiddle with them if you'd like. I'm gonna delete them for the. Thank you. I really need SAT help. So what we do is we're gonna have our main. What we're gonna do is we're gonna create a function. It's gonna be public and static. Its return type will be void, and we're calling it cube. It will take in an int. Hey guys, great. We gotta create our function q.
I use this IQ. What? Wait, can you not just type IQ?
I cubed is I times I times I.
Yeah, but like, can you just type IQ?
No.
How do you get that I on it? I like this. He's 4?
You were 4.
Are you like, are you learning fractions right now? Is that what's going on?
Yeah.
Come on, Asian moves.
Do we got this, guys? Are we ready to go?
Yes.
Okay. How many? So I'm gonna write some code really quick. Okay. So you don't have to write this code. This is going to be a couple of some questions. How many times does this for loop run? How many times does this for loop here?
This doesn't work.
Hey guys, how many times does this for loop run?
Three. So it's a lot. So it's like 999. No, 999.
You know why?
No.
Okay, I don't even know to teach me math. I'm just kidding. I appreciate her existence.
How many times does the for loop run, guys?
Wait, hold on. I'm gonna do some calculations.
Come on, how many? For real though, the questions like this will be on the final. Just FYI. Like,
I'm already screwed.
you're not gonna have a computer on the final, just for the record.
Wait, is it past multiple choice?
1,000.
Most of it.
Is multiple choice?
Most-
Oh, wait, no. Wait, no. Then I got like.
You know, why don't you just say IQ, the biggest cube that's. Fuck. What? What's the biggest cube less than 1,000? Bro. Hey, chill with the language. We have a 3-year-old in the classroom. It's 4. Same thing. 3.5.
How many times does the loop run, guys?
1,000.
1,000 times?
1,000. Yeah.
Yeah, 1,000 times.
Oh wait, I have an error. Correct. Wait, infinity.
Infinity? 1,000?
Infinite? Are you like? Oh, because you said I, the listener. You're wrong. It's 1,000.
For those of you that are thinking for the like first cube that's greater than 1,000, that'd be 10. 10 cube is 1,000. But so we have 1,000, infinity, 10,
9.
9,
Wait, 10.
10.
It is 10.
So
Because I'm a cube, so it's
Stop right there, stop right there.
so it's a cube, so it's only 10 times.
What? What am I doing now?
So 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're done. 0, 1, 2, 3. They add 1, so it's 10. It's the cube of our number.
we got a consensus then? 1,000?
Wait.
10 or 1,000 or
Can I
infinity?
call a friend? Wait. I don't get this.
You can change the value.
Do you know?
Are we ready then?
Wait. It's 10. I get 10. Final answer. I get 10.
Wait.
I got a 10. I get 10. Final answer. Expose me. He's exposing me, right? He will actually.
Ouch, 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 so many errors.
I don't get this.
When am I ever running?
No, you're not. I don't love you, Andy.
Complete honesty.
System.
I don't know now.
I'll take this.
Who?
Who's Doctor Who?
Who?
Wait. Can you read Doctor Zeus?
No. Wait, what? What did they do wrong? I don't know that right now.
I got in the error.
Doctor Who's a woman.
Once.
Can you help me, please? I'm so stupid.
Okay. Error.
Your cash is starting zero.
Can you please help me? What's the heck?
Because there's 0 executions going in.
Can you go on the lower of the link? Oh wait. Counter. Wait.
Here's how many times it runs. Right here.
You are wrong. You said 1,000. It's once. So I think I was a little bit closer. You said 1,000. Yeah.
So,
we were right the first time. You said 10.
okay, so here's what happens in this code. Alright, so here's what happens in Hey guys, here's what happens in the code. We start with our I. I is equal to 0. I is less than 1,000. We call cube I, okay? Ignore the part with the counter because that just tells us what our answer is.
I am so confused.
So
It's okay, you're mine.
here's what cube I does. All it does is multiply I equals I times I times I. What it doesn't do is return anything. We never store any value of I from that method.
Yeah, so it's just one.
So it's just 1,000 runs. It'll give us a really nice large number, whatever 1,000 cubed is, up to that. It'll give us every cube there if we wanted it, but we don't. We do nothing with it, so it executes just 1,000 times.
Because
Is there any questions as to how that works?
I keep getting errors.
You shouldn't have to run the code to know how this does. You should be able to look at the code and get an answer.
I sort of get it and I don't.
Do you guys win?
Yeah, but no, you don't have to.
Well, you don't?
Because he's 46.
So, hey guys, we're good then? We understand what's happening here?
Yeah.
Would you like to see how to make it? So here's the mistake right now. What this is I'm never updating I right here. I'd have to say I equals some cube value to change I, and even then the return type is void. Okay, so that's why there's nothing. That's why that doesn't change anything. Okay. Okay, we're gonna do one more. So, guys, we're gonna make our own method right here. We're gonna make it. Okay. Hey guys.
Oh yeah, totally play Minecraft. You get me a 16 on SAT.
I have an SAT. I'm trying to cross it. What? Majority wins. You are in Minecraft right now.
No, where normally people yours.
This four squares. Did you play? No. I used to. Dude, Longbow was so fun.
Why can't we do that?
I will be the first person to draw 0 on 42.
Are we? Hey guys, we're gonna create our method majority. Take in 3 Boolean values.
True, false, true.
Wait, it would help to not be talking.
What did you get? Stop talking about your 1601 SAT.
I actually don't get what.
Of course you. Chicken nuggets.
We have this, guys?
Yes.
Okay, so guys, here's how this method's gonna work. And then I'm gonna give you your homework as well. You're gonna get a couple minutes to start. You're gonna create this method and one other one. Okay, here's how majority works. Majority is, I'm gonna give you 3 values. They're true or false. It's like yes or no. If 2 of them are true, then I want it to print out true. Okay? If 2 of them are false, I want it to print out false. Okay? It's like a majority vote. 2 people vote yes, 1 person votes no. I want to print out the majority was yes. If 2 people vote no, or 1 person votes yes, the majority was no. 3 people vote no, it's no. 3 people vote yes, it's yes. Okay? That's the first one.
It's really easy. Wait, no.
Okay, so you guys are going to copy this one down as well. This one's called Max 3.
We need to wait for me.
I think you are trying to do
Hey guys, so here's our next one. Our next one is called Max 3. I'm going to give it, basically you're going to get 3 numbers. Figure out which is the biggest of the 3. Okay? And this one, this has an integer return type, so you're going to have to use return. Okay?
So what do you want for this one, kid?
Majority, you mean?
No, for
This?
Max. So you just get
I'm going to give you 3 numbers, and I want you, whatever the biggest of 3 number is to return that number. Whatever it is. So I might give you 0, 0, and 0, so the max of those is 0. If I give you 1, 2, and 18, the max of those was 18. If I give you 8, 1, and 4, the max of those was 8.
How?
That's the part of the thinking.
Slack.
So I'll
So
give.
what is max?
Can you give us some hints? Yeah. Oh.
That's all?
Oh.
You're gonna want to put some code in between these to figure out the max.
Well, you have to put code?
This isn't philosophy class. Oh, what? I thought I was learning German. Parlez-vous français?
Seed. What?
So, I'm going to go over the problems one more time. Because this is your homework, okay? It's two methods. There's public, static void, and majority with 3 booleans. What I want to do is, as long as at least 2 of them are true, of the 3, print out true. If the majority of them are false, print out false, okay? If there are, so, do you know, like, majority vote, okay? You're just going to print out the results of the majority, okay? For max 3, I'm going to give you 3 numbers. You want to find the biggest of the 3 numbers and return it, okay? That is your homework. Good luck.
Wait, so like if A says yes,
True.
and
B says true, so
What
it's
does
gonna
that
out
mean?
true.
Print out true, yes.
Rubber bands?
I will. One thing I will say, guys, another hint, you're gonna want to remember the Boolean logic. What and or are.
Wait.
Less than, greater than, and or.
Oh, okay, I know some of those. You got your second.
Okay. And was the double ampersand, or was the double pipes.
Wait.
If else, very helpful.
I'm gonna need some. Is this a big guy diagram? I know you. Yeah, I don't get it.
Wait, so do we have these cables now? I don't have to. Will you mind here now? Oh, I don't have to bring it? And the cables are right.
Is that a Chromebook?
It's a Surface.
What's a Surface?
Yes.
I'm trying to figure out which laptop I need to call it. This guy has a Surface. So do you.
The great thing about the Surface is you can take notes by hand, but you get the storage, like a storage style of a computer. It's like infinite paper.
Yeah.
Like if you have OneNote.
So it keeps going, right?
Yeah. I can. You use OneNote.
I have before, yeah.
It's like infinite paper. You just keep scrolling down. I can show you how I do it. I don't have them open anymore. So here's like I can print out the textbook into the like one, for example.
Oh, wow.
And I can just like read.
Annotating stuff, whatever you want.
Yeah. So you can do that.
Also, have you taken a data science class by chance?
Data science?
Yeah.
No, I've done like data structures.
Data structures.